Okay, so urban legend says this: water is a good conductor or an insulator. Which one? Conductor, right? Urban legend. False. False. Now, let's keep it safe. Being in water in most situations is extremely dangerous around electricity. But it's false. Clean, very clean, pure water is a very good insulator. Okay? Now what I have set up, I have an amp clamp. And an amp clamp measures electron movement, right? Through, in this case, a wire or a conductor. If water's a true conductor, then I have this hooked up to three-phase, 208 volts. I'm going to close this just so nobody gets killed. And this disconnect is turned off. It is fused. It is protected. It does have a breaker. But I have one jumper wire coming down to this piece of brazing rod. Water between the brazing rods back up to the other side of the line. So if water is a good conductor, then we're going to see current, amperage, moving through that water from one rod to another. Would y'all agree with that? Okay? You wouldn't want to do this outside of a lab without some protection. Okay? Now, I've got my video going here, and it's hard for him to see, but what's the amp clamp saying right now? 0, 0, 0, right? So here we go. We're going to turn on the voltage, and we still see 0. I want to make sure, I'm going to go ahead and turn this to voltage, and 600 volts. And I just want to make sure I do have voltage here. $208 volts, correct? Okay, so there is potential. Right now, if I lick my finger and touch those metal rods, I'm going to get shocked because that's 208 volts, which in residential, that would be 240 volts. Is any current going through the water? Does everyone agree that there is voltage there and there? Is water an insulator or a conductor? Insulator. Insulator. But only what? When it's pure and clean. Do you ever find that in a mud puddle? No. Do you ever find that down on the ground? Did you know that most dirt holds very, very, very high content of minerals? Dirt is, it's minerals. It's ground up rocks, right? So what do I got in my hand?
Salt.
Salt. So we're going to contaminate the water, and we are going to change it from pure H2O to a solution and start adding some table salt, right? And so adding some table salt to that, it's going to take a minute for the solution, for the salt to dissolve, and I may actually have to stir it around just a little bit for this to happen. You want to be careful whenever you're doing this not to add too much at one time. I'm sorry, I was not on, now I'm back on amps. 0.2, it has went up, correct? It was at 0, right? So now it's at 0.2. I'm going to add a little bit more table salt to that. I wish I had what'd it do? It went up. What's it doing? It's going up. 0.5. Now that's 0.5 amps. That's current going through there. Electrons right now are traveling from one to the other, going up. Now what's going to start happening, because current is going through the water's going to start heating. Now, because all of us faculty are geeks, I go into my co-faculty today and I say, hey, hydrogen vehicles have just been approved. In the last 24 hours, the first hydrogen engine in Europe has been approved to put in a vehicle. And so we get to talking, and I said, how is clean hydrogen produced? I'm like, well, I don't really know. Hydrogen is produced by taking two electrodes, putting it in water, and having current go through the water. Right now, the more amps, we're going to go add a little bit more to this. It's going to go up some more. Now that's 0.7 amps. The more electrons that we send through water, the hotter it's going to get, and a very unique reactions happen. We're actually right now creating hydrogen gas. Okay? But does it take current? Does it take energy to produce the hydrogen? So there's no such thing as free energy. So in these hydrogen vehicles, they're still going to have to produce hydrogen with electricity, probably coming from windmills or waterfalls and things like that. Now, I don't know if I quite want to get there. I'm not quite as dangerous as my instructor was. He stayed with this process until arcs, electrical arcs, started shooting through the water. It's not quite getting warm yet. Let's go ahead and play with it some more. Let's get a couple of amps going here. 1 amp. The more solution that I create, saltwater solution, the lower the resistance goes, and the higher the conductivity, and the more current that's going to start passing through the water. Okay, now, don't bump anything. Move in. Listen. Notice the electrons, the electrodes starting to sizzle, starting to boil around those. Those are getting hot. Why? Because we're running 1.5 amps through those. You can hear it. The water's starting to churn. If I added much more salt, it's going to get more erratic. I kind of like it, don't y'all? Kind of fun. 1.7 amps. .8. So, is pure water a conductor? No. Pure water's not. You get it a little bit dirty, then current can go through the water, and it goes from an insulator to a pretty good conductor pretty quick. We're over 2 amps now, which that's a small motor right there. That's a small motor worth of current running. Cooking. You can hear it. We're literally producing. That's not really boiling like you would think, meaning getting up to 212 degrees, right, and causing it to boil. That is producing hydrogen gas. That's what's happening right there. We've produced a hydrogen generator. Thank you.